and they accepted to give us some data for this year. We don't know exactly which BS, what is the architecture, and blah, 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 blah. So it's a bit disappointing, if you want. And because we would need time series, we would need detailed data about different generation, different versions, different manufacturers, different BS architectures, number of antennas, and so on, to understand what is the impact of mobile networks. So the data is available, but is hidden by the manufacturers and the operators. So how to deal with this? How to maybe make a little bit pressure on them? We had a preliminary solution, preliminary answer. We tried to estimate the power based on a simplified model on open data that is available in France and on some reasonable assumptions. So this is what we have done in this work. So first we have based our work on the NFR data set. So this is a French agency for frequency management in France. And we have processed the data set. We have also shown the hierarchy of the data set. So because this data set is not well documented, so the code and the documentation we have written is available online on the GitHub. And we have this kind of information like the support of the base stations, the antennas, the transceiver, the bands, and so on. There is some important information are missing, like the transmit power or the number of antenna elements in MIMO, for example. But we can deduce some things, and we can and there is already a lot of information. So we have processed this, and we have based our models on two kind of base station architecture. Let's say old one and a new one. So in the old one, this is here on the top. You see that you have supply, electricity supply elements. You have cooling. You have a baseband board, which is a card dedicating to signal processing. And you have the radio frequency part, the power amplifier, and you have the antennas with a cable, which is the feeder. And in a more more modern architecture, the power amplifier are deported in a radio head, in a remote radio head. And so generally that is connected with optical fiber to the base station. So there is no cooling. Cooling is done by the air. And there is no feeder loss because this is optical transmission. And then we have the output power for the antenna. We have used widely, a bit old, but widely accepted model, which is the Earth model that predict a little bit the power consumption of a base station as a function of the element we have seen. So you have the consumption, for example, of the power amplifier, you have the baseband board, and you have losses you see on the denominator related to the supply or to the feeder or the cooling. And the power amplifier is characterized by an efficiency parameter that is called eta here. So this is for the old base stations. For 5G, we know that 5G now is using massive MIMO, so it means that it requires antenna array units. And so we have based our calculation on another model, which looked better for us with respect to informal discussion we had with some operators. And we have made a dependence on load, but we are using an average load, so we just multiply the average load rho by the maximum transmit power. We have taken into account technology improvement, so over the years, the technology is improving, and so, for example, here, this is the case of the power amplifier efficiency. It is improving after N years, it is better. And we have an assumption on the average BS lifetime. So after some time, the BS is replaced with a new technology. So I don't have so much time, so I go directly to the results. So the numerical settings, so we have most of the values that are taken from these two references. We have our own assumption for the mapping between the BS type and the technology, because between the MIMO type, the technology, and the frequency band. So this is our own assumption. And we have obtained this kind of results where you see on the left the number of base stations in France, between 2015 and 2022. And the straight line is the introduction of 5G. So we have base stations that are multi-technology. So for example, take this curve, it's a 2G, 3G, 4G base stations. So they are increasing until 5G. And then they have been upgraded to 5G. So you have this curve. So these base stations are decreasing and the number of base stations with 5G is increasing. And here at the top, you have the total amount of base stations in France. So we see that the rate of increase is quite high, okay, maybe 7 or 8%. And if we go deeper, I mean, we look at the number of transceivers, the rate of increase is even higher, maybe 18%. And after the introduction of 5G, we don't have, the growth rate is not deviating too much because 5G is probably co-located with 4G most of the time. And also because some 2G and 3G components are decommissioned. So if I translate now, I plug my model, my power model on this database and on these numbers, we see a very big increase, in fact, of the total consumption power of the BS, maybe multiplied by 3 or 4 within 7 years. And the total consumption is here 350 megawatts, so it translates into 3 terawatt-hours per year, so approximately a bit less than 1% of the total electricity consumption in France in 2021. The growth rate has accelerated a little bit from 18 to 19% by the introduction of 5G. The reason also is the fact that the base stations are bigger and bigger. So here we show the average base station power as a function of the highest technology. So here on the right you have the 5G case, and on the left you have only 2G base stations. So the increase is quite important. We have compared to other sources, so 2 main sources from Linden et al. And from document from the French regulator ARCEP. We are not so close, but we are in the same order of magnitude. It's difficult because it's not exactly the same scope, so we have to make some rough scaling. I can explain if you want afterwards. We have also sampled data taken from, for example, the operator Free in 2017, or from ITU and so on, about the consumption of 5G base station, and we are in the same order of magnitude. So as a conclusion, in our study, everything is available, is open, okay? So the NFR dataset, the power model, the source code, so suggestions are welcome. And it seems that we underestimate the power consumption with respect to existing study, but we are in the same order of magnitude. And we have impressive, maybe alarming figures between 2015 and 2022. So in terms of equipment count, but this is not from us, this is from the NFR dataset, and probably in terms of power consumption, and this is with our assumptions. So keep in mind that the mobile data traffic has increased by 37% between the 2 dates in the meantime. So we see also the increase of energy efficiency. 5G has not significantly modified the increase rate in terms of equipment count, as I explained before, and but maybe an acceleration of the growth rate of the total power consumption. Thank you for your attention.